This morning in the Atlanta airport, no one's missing a meal on Mac Wilburn's watch. With 11 restaurants to serve passengers, he's got dining for every destination. And it all started when Mac talked with First Horizon Bank about opening a franchise in the airport. Now it's open for business and cleared for takeoff. First Horizon Bank. Let's find a way. Go to firsthorizon.com/Mac. First Horizon Bank, member FDIC. Tonight in Arkansas, there's a mother tucking in her daughter and turning off the light. A business owner's burning the midnight oil. An at-home dinner date is plating up possibility. And it's all happening under one roof. How? The power of a conversation, like the one John from Integrity Solutions had with First Horizon Bank about his vision for a sustainable mixed-use building. Now it's not just words, it's life. First Horizon Bank. Let's find a way. Go to firsthorizon.com/John. First Horizon Bank, member FDIC.
Hello and welcome again to Astronomy Daily. I'm Steve Dunkley, your host. It is the 22nd of May 2023. Today we'll be looking at the 600th person in orbit, another way to measure the expansion of the universe, and a launch from New Zealand of all places.
Astronomy Daily, the podcast, with your host, Steve Dunkley.
Yes, that's right. There's been some big happenings in the sky and on launch pads and in the space industry all over the world today, but especially in New Zealand. They've sent a few bits and pieces into orbit. Oh, well, they were going to anyway. We'll get to that later. But would you welcome my fabulous digital sleuth, Hallie? Thank you for joining us again, Hallie.
Hi, again, my favorite human.
Of course, it's not the New Zealand launch that's got everybody's attention today, is it?
Everyone is talking about the launch today.
That's right, the 600th person into orbit. That's a new milestone.
That's funny. In Australia, you still say milestone when you use the metric system.
I know, it's just old habits.
But this is an exciting event.
It sure is, Hallie.
Humanity is inching its way into space.
Not centimetering?
There's no such thing, Steve. Don't be silly.
Okay, I'll try to be sensible from now on. What have you got for us?
Okay, time for the short takes. As stars up to 8 times heavier than our sun start to run out of nuclear fuel in their core, they puff off their outer layers. This process gives rise to the colorful clouds of gas misleadingly known as planetary nebulae, and leaves behind a dense compact hot core known as a white dwarf. Our own sun will undergo this transition in 5 billion years or so, then slowly cool and fade away. However, if a white dwarf somehow puts on weight, a self-destruct mechanism kicks in when it gets heavier than about 1.4 times the mass of our sun. The subsequent thermonuclear detonation destroys the star in a distinctive kind of explosion called a Type Ia supernova. But where would the extra mass come from to fuel such a bang? We used to think it could be gas being stripped off a bigger companion star in a close orbit. But stars tend to be messy eaters, spilling gas everywhere. Supernova 2020 IJ was discovered by a telescope in Hawaii on March 23, 2020. For the first 7 weeks or so it behaved in much the same way as any other Type Ia supernova. But for the next 5 months, it stopped fading in brightness. It also began to show features indicating gas that was unusually rich in helium. Astronomers began to suspect Supernova 2020 IJ belonged to a rare subclass of Type Ia supernovae, in which the blast wave, moving at more than 10,000 kilometers per second, sweeps past gas that could only have been stripped off the outer layers of a surviving companion star. One of the more remarkable properties of Type Ia supernovae is that they all seem to reach pretty much the same peak brightness. This is consistent with them all having reached a similar critical mass before exploding. This very attribute allowed astronomer Brian Schmidt and colleagues to reach their Nobel Prize-winning conclusion in the late 1990s. That the universe's expansion since the Big Bang is not slowing down under gravity, as everyone had expected, but is accelerating due to the effects of what we now call dark energy. So, Type Ia supernovae are important cosmic objects, and the fact we still don't know exactly how and when these stellar explosions occur, or what makes them so consistent, has been a worry to astronomers. Our hypothesis, and radio confirmation, that supernova 2020 occurred when enough helium gas was stripped off the companion star and onto the surface of the white dwarf to push it just over the mass limit, provides a natural explanation for this consistency. A new pair of NASA weather satellites was scheduled for launch today, but according to Rocket Lab's Twitter page, the mission, which is called Coming to a Storm Near You, has been delayed by, you guessed it, a storm. The company is now looking at May 25th as a proposed launch date. The numbers 5 and 6 tropic satellites are part of a constellation of extreme weather observatories, also known as CubeSats because of their small size and low weight. This launch will send 2 more tropic satellites to join 2 previously launched sats. NASA chose Rocket Lab, a company that launches from New Zealand, for the missions. The launch site makes it possible to achieve low Earth orbital paths for the majority of missions the satellite industry needs. NASA's main goal is to keep an eye on the formation of sudden weather phenomena, mainly hurricanes and cyclones, to improve forecasts given the severe impact they can have on the regions they hit. Each tropic satellite carries a high-performance radiometer monitor that scans across the satellite track at 30 revolutions per minute. This observing system provides a combination of horizontal resolution related to time, while measuring environmental conditions in the cores of tropical cyclones in a nearly global scale. According to company officials, operating a private orbital launch site, alongside its own range and mission control centers, helps Rocket Lab to contain mission costs, which makes affordable and effective launch services. 2 years after awarding Elon Musk's SpaceX a contract to ferry astronauts to the surface of the moon, NASA on Friday announced it had chosen Blue Origin, a rival space company founded by billionaire Jeff Bezos, to build a second lunar lander. Blue Origin's lander was selected for the Artemis 5 mission, currently scheduled to take place in 2029. The company will first have to demonstrate it can safely land on the moon without a crew. The contract amounts to $3.4 billion, but John Coulouris, vice president in charge of lunar transport at Blue Origin, said during a press conference that the company would itself contribute well north of that amount to develop the craft. The Artemis program marks NASA's return to the moon after more than 50 years and is made up of several missions, each with increasing complexity. In 2021, the U.S. agency chose SpaceX to build a lander for Artemis 3, the first mission in the series to have actual astronauts set foot on the lunar surface. Blue Origin had also competed for the first contract and filed an unsuccessful lawsuit against NASA when SpaceX was chosen as the sole lander provider. Blue Origin's lander, dubbed Blue Moon, is being developed with several partner companies, including Draper, Boeing, Astrobotic, Honeybee Robotics, and Lockheed Martin. The latter will be responsible for developing a crucial element. Once in lunar orbit, Blue Moon will need to be refueled before it can descend and collect the astronauts from the surface of the moon. Therefore, Lockheed Martin has to develop a kind of shuttle to refuel Blue Moon around the moon. And that's all I have at the moment. Back to you, Steve.
Astronomy Daily,
The podcast.
Wow, doesn't that development of the Artemis mission sound exciting, with refueling craft orbiting the moon? It just sounds fantastic. That's science fiction becoming science fact. I can't wait to see some of those things unfold. Very exciting.
Introducing Carvana Value Tracker, where you can track your car's value over time and learn what's driving it. It might make you excited.
Whoa, didn't know my car was valued this high.
It might make you nervous.
Uh-oh, market's flooded. My car's value just dipped 2.3%.
It might make you optimistic.
Our low mileage is paying off. Our value's up.
And it might make you realistic.
Car prices haven't gone up in a couple weeks. Maybe it's time to sell.
But it will definitely make you an expert on your car's value. Carvana Value Tracker. Visit Carvana.com to start tracking your car's value today.
Well, the big story at the moment is the 600th person to enter Earth orbit is now on her way to the International Space Station. In fact, at about 1 o'clock this afternoon, Eastern Australia time, she would have docked with the ISS. Raina Banawi on Sunday, that was yesterday for us here in Australia, lifted off with fellow Saudi Space Commission astronaut Ali Al-Khani, sorry about my pronunciation, folks, privately funded astronaut John Schaffner of Tennessee and former astronaut Peggy Whitson on the second mission organised by Houston-based space services company Axiom Space. The 4 Axiom 2 crewmates launched at 5:37 Eastern Daylight Time on the SpaceX Dragon spacecraft Freedom atop a Falcon 9 rocket from 39A pad from the Kennedy Space Center in Florida. Less than 9 minutes later, Banawi and her crewmates began circling the planet. Al-Khani and Schaffner are first-time flyers, but based on a precedent set in 2021 when the 600th person entered space, a figure that also included suborbital flights, the count is based on the astronauts' mission designations. As pilot, Schaffner became number 598, Al-Khani is number 599, flying as Mission Specialist 1. As such, Banawi as Mission Specialist 2 claimed the round number, and with Banawi only 72 women helped comprise the 600th person total. I feel incredibly humble to follow in the footsteps of many astronauts and pioneers before me, Banawi said in a statement. As the 600th person to enter orbit around the Earth, I'm excited to represent the Kingdom of Saudi Arabia and the Saudi Space Commission during this historic mission. It's a true honour to be a part of the mission that is expanding access to low Earth orbit for people like me and you who are to be able to inspire people around the world and reach for the stars and pursue their dreams. Banawi is now the first Saudi woman to fly in space and the first Arab woman into Earth orbit, with Al-Khani the first Arabs and Saudis to launch together on the same mission. The first Saudi and Arab astronaut to fly, Sultan bin Salman Al Saud, did so as payload specialist for the Space Shuttle Discovery in 1985, all that time ago. Once they arrive at the ISS, which is expected to, well, it happened at 1 o'clock daylight time here in Eastern Australia, Banawi and Al-Khani will be greeted by the station's Expedition 69 crew, including Emirati astronauts Al-Sultan Al-Nayadi, marking the first time 3 Arab astronauts have been in space at the same time. Banawi, 33, Al-Khani, 31, are not the only record setters on the AX crew. Schaffner, 67, is the first person to have been born in Alaska Fairbanks to fly into space. So I think it's a very odd sort of a thing to say, because if somebody from my town went into space, they would also be the first person from my town to be in space. Don't you think that's odd? No. Peggy Whitson, as a former NASA astronaut, already holds the distinction as the most experienced American and woman to fly into space, having previously logged more than 665 days on 3 long-duration stays aboard the ISS. She will add to that count on this mission, which is expected to last about a whole 10 days. Whitson, 63, is now also the first woman to command a commercial spaceflight. She joined Axiom Space after retiring from NASA in 2018, becoming the company's director of human spaceflight. Whitson is the second former NASA astronaut to fly for Axiom, following Michael Lopez Alegria on Axiom 1 in 2022, and the third NASA astronaut to return to space after leaving the agency following John Glenn in 1988. Isn't that interesting? During the next week at the space station, Whitson will assist Schaffner, Al-Khani and Banawi proceed through their planned science and outreach programs. The AX2 crew plans to conduct more than 20 different experiments, including research into stem cells, DNA-based nanomaterials, and cancer countermeasures. They will also photograph lightning strikes and high-altitude transient luminous events, known as sprites, and test a wearable skin suit that simulates Earth's gravity to counteract the negative effects of microgravity. As you know, the human body does not like living in no gravity. It tends to shed things like calcium and other things, and it's not very happy in zero gravity. So it'll be interesting to see how that works out. Schaffner, a race car driver who has aspired to fly in space since his childhood, will use part of his time to announce the winners, get this, of a Crayola-sponsored art and poetry contest that was open to children from around the world. Al-Khani and Banawi will interact with students in Saudi Arabia with the goal of inspiring an interest in science, technology, engineering and mathematics education. We're going to be doing 3 education awareness experiments with kids, said Al-Khani during a pre-launch press conference. It's going to be a live event, which is going to be amazing for them because it's going to be a huge opportunity to compare the results that they had on the ground with the ones we are going to have aboard the ISS. Now that is going to be interesting. Al-Khani and Banawi are going to be bringing a taste of their country to their temporary home in orbit. We are going to be taking with us Saudi coffee and dates to share with the astronauts on board the ISS. Fantastic. Banawi has a Saudi flag and packed earrings from her grandmother, who was not able to attend the launch but gave her blessing for the flight. Whitson has again flown with a necklace that she wore at her wedding and then flew on her 3 previous missions. Schaffner, you're going to love this, chose something that represents his lifelong dream of flying in space. He says, "When I was 8 years old, I built a model of the Gemini spacecraft. It had little astronauts in it that would come out, and I happened to have one of those from 1963, one of those little astronaut guys, probably Ed White," he says. He says, so that one's going up with me into space again. That's fantastic. I love that. It sort of puts a real human complexion on these people who have done this jaunt into space. That's like this ultimate adventure, but they're still very human. They're taking these little trinkets with them. One other astronaut above the spacecraft was Gigi, the mission's zero-G indicator, and AX02 fifth crew member, the result of a partnership between Axiom Space and Build-A-Bear Workshop. The fuzzy bear was dressed in a miniature version of the Axiom's prototype spacesuit, which the company is developing for NASA astronauts to wear on the Artemis 3 moon landing. Oh, fantastic. Oh dear. Axiom 2 is the second flight for Dragon Freedom, which previously flew SpaceX's Crew 4 astronaut mission to and from the space station. Private missions like AX2 are part of NASA's strategy to help build a low Earth orbit economy, such that companies like Axiom Space can operate commercial orbit facilities after the ISS is retired. What a wonderful story. A cosmic lens magnified the light of an exploding star. Now, astronomers are using observations from that supernova to calculate the universe's current rate of expansion. Stars explode all the time in the universe, but the supernova that Patrick Kelly found in 2014 marked serendipity at its finest, an explosion not only caught in the act of detonation, but also magnified by the gravity of confluence of foreground galaxies. Now, Kelly, from the University of Minnesota, is leading a team in using this serendipitous supernova to get an independent measure of the universe's current expansion rate. Astronomers have been debating intensely for about a decade. Although the new measurement won't settle that debate, it does provide an independent method that astronomers badly need. Supernova Refsdal, named after Norwegian astronomer Søren Refsdal, just happened to go off under a cosmic lens from Earth's point of view. A massive galaxy cluster magnified the supernova's light and bent it, splitting it into separate but identical images. Kelly, who is a graduate student in 2014, was searching the Hubble Space Telescope's images by eye, spotted 3 bright images and contacted his team straight away. A fainter 4th image was found later, and it was immediately clear, he said, that it was very exciting. But the physics of gravitational lensing, which is the same as for eyeglasses, should have created not 4 but 5 images. 1 image was missing. Kelly and his colleagues predicted that the light of the final image might be travelling a longer path to Earth through the cluster than that of the others. Depending on the path travelled, they figured it would appear anywhere from a year to a decade later. And a year later it did show up. A new study published in Science explores what supernova Refsdal can tell us about cosmic expansion. The universe has been expanding, so the theory goes, since the Big Bang. although at different rates. Astronomers have measured the rate at which the universe is currently expanding, called the Hubble constant, in many different ways. These ways often rely on carefully calculated distances, but the measurements have become more precise and the answers have split between two numbers, creating tension. While this tension is regarded as a potential problem for the standard model of cosmology, which includes mysterious dark matter and equally mysterious dark energy, there's still the possibility that the different answers come out due to systematic errors in the measurements themselves. Supernova F-style offers a new way to estimate the Hubble constant that, while not free of systematic errors, is at least free from the ones that plague the other estimates. To calculate the Hubble constant, Kelly and his colleagues first need to determine the distance to the supernova based on the last image's delayed arrival. The time delay itself is more precisely estimated in an accompanying paper published in the Astrophysical Journal. To do that, they first need to properly account for the distribution of mass in the intervening galaxy cluster, since the cluster's gravity is what's bending the light. Understanding its mass distribution is basically like knowing the prescription of the cosmic lens. Using a set of cluster models, Kelly's team arrives at an estimate of the Hubble constant that's between 63.3 and 70.7 kilometres per second per megaparsec. There's a lot of wiggle room in that answer, but it's in line with what astronomers have previously found by analysing observations of the cosmic microwave background taken from the Planck satellite, and it's below the other set of estimates, such as that from the SHOES collaboration based on observation of Cepheid variable stars and type Ia supernova, as well as from the Holy Cow team that studies distant lensed quasars. Christopher Koshanek from Ohio State University, who wasn't involved in the study, says that it's a solid result, but he questions whether the new measure is precise enough to be useful. The measurement's uncertainty is 6%, and you need a 1 or 2% measurement to be competitive, he says. The devil is in the lens model, he adds. Kelly's team applied many models and then calculated a sort of weighted average of the results that helped make their measurements more precise. But Koshanek explains that a weighted average only works if the uncertainty of any one model is random. Kelly's team agrees that the lens models are indeed the sticking point when it comes to precision, noting that if the cluster's mass distribution were known exactly, they'd be able to measure the Hubble constant within 1.5%. With improved models for the cluster's mass based on James Webb Space Telescope observations, more precise measurements may come from supernova F-style. Finding more lens supernovae will be the key to better understanding the Hubble constant. In fact, astronomers recently announced another lens supernova in new James Webb observations. Certainly the same method will also be applied to the myriad lensed supernovae that the upcoming Vera C. Rubin Observatory will find. And I'd like to acknowledge Monica Young for the wonderful research on that article. And that's it for another episode of Astronomy Daily. I hope you got something out of that today. It's been a very exciting day in space. So, like we keep saying, keep your eyes on the skies. And Hallie, what do you say?
Just a reminder that all the past episodes of Space Nuts with Andrew Dunkley and Professor Fred Watson can be found on the Space Nuts website.
That's right, it's spacenuts.io is the address. You'll find all the episodes of Astronomy Daily there as well.
And don't forget to say hi on the Space Nuts Facebook page.
And that's it for us. I'm Steve Dunkley, your host. See you later.
Bye.
Astronomy Daily, the podcast, with your host, Steve Dunkley.